Find all values of the parameter a for which the quadratic equation a plus 1 x square plus twice of a plus 1 into x plus a minus 2 equal to 0. This is a quadratic equation. So if it is a quadratic equation, then coefficient of x square must not be equal to 0. So we will take this as a condition. We have a plus 1 not equal to 0. If a plus 1 is not equal to 0, then a must not be equal to minus 1. If a equal to minus 1, this whole will become equal to 0, and this quadratic equation will become even not a linear equation. So because even if I substitute here minus 1, again this will become 0. So a will be equal to 2. Okay. So now we have to find the values of the parameter a for which the quadratic equation has two distinct roots. Okay. So what we'll do is first we'll find the discriminant of the above quadratic equation. Discriminant is b square minus 4ac twice of a plus 1 the whole square minus 4 multiplied by a is a plus 1 multiplied by c is a minus 2. So I will evaluate this. So 4 multiplied by a plus 1 is taken as common. Remaining is a plus 1 and minus a, minus of minus is plus 2. So plus a and minus a will get cancelled. So 4, 2 plus 1 is 3, 4 into 3 is 12 multiplied by a plus 1. Now let me consider the first case. The first case is I have here as it has two distinct roots. Okay. So if it has two distinct roots, then its discriminant will be greater than 0. Its discriminant is greater than 0. So I must have 12 multiplied by a plus 1 greater than 0. That is a plus 1 greater than 0. Then a is greater than minus 1. So then this condition will get satisfied. Now we'll go to the second case. The second case is it has no roots. If it has no roots, then its discriminant will be lesser than 0. If discriminant is lesser than 0, a plus 1 will be lesser than 0. Then a will be lesser than minus 1. So if a is lesser than minus 1, let us check here. If I have delta lesser, a is lesser than minus 1, which is not possible. So this is not possible because I have in the first condition as a is greater than minus 1. The third one we have the equation has two equal roots. If the equation has two equal roots, then its discriminant must be equal to 0. If its discriminant is equal to 0, then a plus 1 will be equal to 0 from here. Okay, then a will be equal to minus 1. So which is not possible, and this contradicts the hypothesis, because if a plus 1 is equal to 0, then the quadratic equation will not exist here, and it is given that a must not be equal to minus 1. So find all values of the parameter a. So what will be the value of a? A should be greater than minus 1 will be the value.